Okay, let me go ahead and, before we get started on number 1 and 2, let me talk to you a little bit about what function means. This notation is called function notation. It means the same as y equal. Both of those are the height of a function. The x value, so the f of x, it's whatever the x value is. So when you input an x into the function, you're going to output the height, or the y value. Okay, so every time you have an ordered pair, a single ordered pair is called a relation. If you have a group of ordered pairs, that's a group of relations, but sometimes relations form a function and sometimes they do not. So let me give you an example. So you've got a parabola, and by the way, all polynomials, so y equals mx plus b, y is equal to x squared, y is equal to x cubed, so forth. All of these are polynomials, and this is why. When you graph this, there's this thing called a vertical line test, and visually this is a very good thing to show students when you're talking about functions. If you take a vertical line and you run it through any point along a function, you could do that an infinite number of times because that graph goes on infinitely. Notice each time it touches the graph in one location. This would be a function. So what if we had an ellipse, and that's something that they would study, say, in Algebra 2 or in pre-calculus or college algebra. Let's say you had an ellipse, and that's a special type of conic section, and I mean a special type of quadratic function, or I should say non-function, but it's in that quadratic family. But look at what happens when you try to do a vertical line test. There are two outputs. So let's say this is -2. So -2 is the input, but -2 has two outputs. It can't be a function. So let's say this is -1. Let's say this is +2. So one kind of working definition of a function is that for every function, this is the input, there could only be one output for each input. Now, let me show you another example. Let's say we have a horizontal line. And let's say this is up at 4. Well, look at that. All of these values are 4. Right? These, but let's do a vertical line test. So look at what we have. -4, -3, -2, -1, 0, and it goes on. Each of those inputs, each has only one output. -4 has the height of 4. -3 has the height of 4. So there can be repeating y values. There cannot be repeating x values. Each x value can only have one output. So let's come over here now. Okay, we want to represent relations as a set of ordered pairs. So you come over, here's your x and y, -4, 7, 2, 7. I guess I don't need to read those. Want to represent it as a graph. So -4, 7, +2. Whoops, that's +2, not +1. positive 2, 7, positive 3, 6, 5, 2, okay, so now look at, check to see if it passes the vertical line test. So if we do a vertical line through that point, it only touches once, only touches once, only touches once, only touches once. So we know right away, looking at the table, none of those x's repeat. If we look at ordered pairs, none of those x's repeat. And then also, if we look at the table, there it passes the vertical line test. All right, so then we're going to go to mapping, and you put them in least to greatest. Whoops. And the y values, there's y, a height of 2, a height of 6, and a height of 7. And then you always go from x to y. You always map going that way. So at negative 4, we have a height of 7. At positive 2, we have a height of 7. At 3, we have a height of 6. 5, we have a height of 2. And 7, we have. So notice, if you look, each one of those x values only has one arrow. Now, there are several arrows pointing at the 7. It doesn't matter. You just like the horizontal line, all of the y values can be the same number, but you can't have two arrows going from a mapping. So, well, let me go ahead and write domain. You're going to have a list and then range. The domain are all the x values. Range are all the y values. So this direction, this direction. So we can look here. We have negative 4, 2, 3, 5, and 7. So negative 2, negative 4, 2, 3, 5, and 7. Now let's look at the heights. We have a height of 2, a height of 6, and a height of 7. So that's the domain and range. I think I probably don't have to do the second one. You do it just like this. But the bigger idea is explaining the idea of a function, no repeating x values, and please, when you're talking about functions, explain that every time you see f of x equals, you're looking for the height at a given x value. So for example, let's look at f of negative 4. The height is positive 4. Here's the input. Here's the output. The output is the height. Okay, I think that should cover it. Have a good week.